7.1 first sum. A job production unit has 4 jobs A, B, C, D. Sorry, 4 jobs A, B, C, D which can be manufactured on each of the 4 machines P, Q, R, S. Machine P, Q, R, S. The processing cost of each job for each machine is given below. In this question, you have been given 4 jobs P, Q, R, S. These 4 jobs can be done on 4 machines, machine 1, machine 2, machine 3 and machine 4. Here machine 3 will be there. Machine 3 and machine 4, and in these columns and rows you have been given the processing cost, that is cost of doing job P on machine 1 is 31 rupees, on machine 2 is 25 rupees, on machine 3 33 rupees, on machine 4 29 rupees. So you can see that same job P is done on every machine but at different cost. Each machine has different cost of doing job. Now you have to find the optimum assignment to minimize the total processing cost. You have to assign each job to each machine such that in minimum cost all the 4 jobs are completed by 4 machines. Now we will solve this sum by Hungarian method. In the Hungarian method, first step is to subtract the smallest value of each row from that row. Now first you have to find smallest value of each row. In first row smallest value is 0. We must start with a question. In the first row smallest value is 25. In the second row smallest value is the 21. In the third row smallest value is 19. In the fourth row smallest value is 34. I have underlined smallest value in each row. Now you must subtract this smallest value from that particular row. So 31 minus 25 6, 25 minus 25 0, 33 minus 25 8 and 29 minus 25 4. Now in the second row smallest value is 21. So we will subtract 21 from every element. 25 minus 21 4, 24 minus 21 3, 23 minus 21 2 and 21 minus 21 0. In the third row smallest element is 19. 19 minus 19 0, 21 minus 19 2, 23 minus 19 4, 24 minus 19 5. In the fourth row smallest value is 34. 38 minus 34 4, 36 minus 34 2, 34 minus 34 0, 40 minus 34 6. Now step 2, step 1 completed. Step 2, you must subtract. Second step is subtract the smallest value of each column from that particular column. So in the first column smallest value is 0. In the second column smallest value is 0. In the third column smallest value is 0. In the fourth column smallest value is 0. Now we will subtract smallest value from that particular column. Now 6 minus 0 6. Since smallest value is 0, if we subtract 0 from every element will remain unchanged. 6 minus 0 6, 4 minus 0 4, 0 minus 0 0, 4 minus 0 4. So same element 6 4 0 4 will come. In the second column also 0 is the smallest element. If we subtract 0 from each element, same answer will be obtained. In the third row also smallest element is 0. If we subtract 0 from each element, same answer will be obtained. In the fourth column also smallest element is 0. So if we subtract 0 from each element of this column, same answer will be obtained. Now step 3. Step 3, you have to find out, you have to examine each row and find the row with the single 0 and mark it, and cancel all the zeros in particular row and column. That means that you have to examine the row, and where there is a single 0 you should mark an assignment. In the first row there is a single zero, so please mark it, make assignment. In the second row also there is single zero, so please mark it. In the third row also there is a single zero, so please mark it. In the fourth row also there is a single zero, so please mark it. Similarly, you must examine column also. In the first column also there is a single zero, so please mark it. Whenever you mark zero, suppose I am marking zero here, every zero in that particular column and that particular row should be cancelled. Here there is no zero and here also there is no zero, so I am not cancelled. When I mark zero in the second row, in that column particular and that particular row there was no zero. If there is any zero in that particular row or column, you should cancel it. In the third row, when I mark this zero, there was no zero in the particular column and in particular row. Now in the fourth row, when I mark this zero, because there was single zero, there was no zero in that particular column and that particular row. If any zero comes in that particular column or row, you should cancel it. Now you should examine column wise. Column wise, when you examine, you will see that in the first column there is a single zero that already have been marked. Now in the second column also there is a single zero that already have been marked. Whenever we mark zero, if there is any zero in that particular column or row, we should cancel it. But there are no such zero in this sum. In the second row also, when we mark this zero, there is no zero in that particular row and that particular column. In the third row, single zero is here. When we mark it, there is no particular zero in that column and that row. And in the fourth column, there is a single zero, so we will mark it, and there is no zero in that particular row and particular column and particular row. Now, if you observe, there is exactly one assignment in every row and column. In every column and in every row, exactly one assignment is obtained. So our sum is solved and optimal solution is received. Now we will write the optimal solution. We will write job, machines and processing cost. Now job P should be given to machine 2 because there is an assignment there. So P job should be given to machine 2. Q job should be given to machine 4. R job should be given to machine 1 and S job should be given to machine 3. Now we will write processing cost. Now you compare question with this answer. Here there is a 25 rupees cost, so we will write 25. Here in the second row there is 21 rupees, so we will write 21. Here in the first column there is 19 rupees, so we will write 19. And here in the question there is 34 rupees, so we will write 34. And when we add this, total cost is 99. So total minimum cost is rupees 99. This is the answer.